This is KBYP's Real Ham Radio Video Antennas and Transmission Line Series number 10. Real Ham Radio is what's on the inside. See the inside? That's real radio. That's inside a Drake TR4C. And this video is going to be inside how a loop, which I showed in a previous video is not an antenna, becomes an antenna. The previous video observed that a loop is a turn of an inductor and it tries to conserve its field to the inductor and return to the circuit from where it came. To do the antenna function, there has to be charge movement and field coupled to something to something. And if that loop is in outer space, it has nothing to couple to establish field lines, so it's not an antenna. This is the, ubiquitous Saturn Halo 6-meter loop they called an antenna. It is poorly. But this thing was famous from the 1950s for being able to go mobile with 6 meters. It consists of 3 rings. The top one is a loop across a feed point. The 2 below are tied together and magnetically, I think, coupled to the first one. I don't recall exactly the arrangement. It has a feed point that's about 25 ohms. Requires a 2-to-1 transformer according to the instructions to go to 50 ohms. Well, that's poor because they're transformer losses. I got one of these on a junk pile, rebuilt it, had an analyzer on the feed point and was reading, by golly, if I move things just right and spread the loops a bit, I was reading between R50 and R70 something. Take a little bit of reactance away, and that's a perfect match without a transformer. So I happily took the antenna outside, put it up on a wooden pole, and the match wasn't worth a tinker's cuss. Horrible mismatch. What happened? Well, it was no longer resistive. Something changed. What was it? Nothing changed in the loop. And notice I didn't call it an antenna. It was exactly as it was when it was laying in this orientation on the bench, except I took it outside and put it vertically up 6 feet on a pole. A little higher than it would be on a car, probably. On the car, it tended to be a foot or 2 above the roof line. The only thing that changed from here being resistive and close to a feed line match to here, and exactly the same structure, was its orientation was changed, and it was taken away from close proximity to a wooden workbench with carpet. In fact, this workbench, just ordinary 2x4 and plywood workbench. Being somewhat befuddled and bewildered, I took the pole with the loop on the end and laid it on a wooden table on top of the deck outside, with it in this orientation with the bottom there of the loops probably 3 feet from the ground, and got a resistive reading. And I found that when I raised it away from both the table and the ground, the resistive component disappeared. Basic antenna theory. This is not an antenna. There's no field. A point in outer space has nowhere to couple field to. There's no other point, no other charge to couple field to. Therefore, it can't generate electrical and, when moving, magnetic fields, and that's what's necessary to make an antenna and make so-called radiation. The fact that it loaded here proved that there was coupling between the loops and the wooden bench, and of course, to some extent, the wall behind it, because there was a wall about 2 feet behind looking in this view. What happened here is that there was coupling between the loops and the wood, comprising an antenna, whereas it did not exist here. In theory, if I had put up a wooden panel in a similar orientation here as was here, this might have tuned. It would be a real problem driving down a road with that. It's not going to work. And this shows a principle of going from what's not an antenna, as in the previous video, because the length of wire in free space has nowhere to couple field lines to a conductor, in this case a loop, above a plane. I'll take that loop, the one on the left, which is the one that's loaded, that has a feed line connection, straighten that out, and you've got part of a dipole arm above a plane, and that's a dipole, or part thereof. And that demonstrates a coupling between the dipole arm and the ground, which comes to a very interesting point. As in the previous video, segment of a dipole arm and a plane opposing it, not necessarily ground. Actually, outside, that's called earth. That's not just ground. If you watch my videos, you'll see me cuss ground radials up one side and down the other because they're horribly lossy. So says Radio Antenna Engineering by Laporte. In my opinion, the ultimate antenna book. Ground radials have horrifying losses. This dipole wire above a plane ground does not. And my 20-meter dipole, that worked I1YRL last night at 413 Zulu on 14025. I had a 5/8 signal into Italy with about 5/8 of a watt on my dipole. There can't be any losses, any significant losses in this system of this wire above ground. If I'm working in Italy with that kind of power, he was running 80 watts and a 7-element Yagi, and his report was 5.3. I'm burning holes in Europe of less than a watt with a dipole above a horrifyingly bad ground. It's almost all clay. The only saving grace is that it's wet, and water is a high dielectric constant, perhaps a better conductor than just clay, but this soil here is absolutely awful, according to conventional thinking, yet this antenna works absolutely stunningly well. With less than a watt at the feed point, I'm estimating 5/8 with a watt from the transmitter, and about, I think it's 108 foot of building 9604. So I'm guesstimating about 5/8 of a watt because they're transmission line losses. If this ground were acting horribly lossy, they wouldn't hear me in Italy. What's happening here is not what's happening with the ground radial, because the ground radial is in intimate contact with current flow, albeit the current does not flow along and through wires. Current flows in wires. Look up diffusion current. But here the coupling is for the electrical fields perpendicular between the wire and the ground, not along the ground. It's coupling to the surface of the ground, but obviously not inducing losses. And there's a video on YouTube by someone pretending to be the penultimate Elmer blowing smoke up your ass about how it's critical to find a location that has good ground. Well, the practice of putting a Yagi up 100 foot from the ground completely separates the antenna from ground, so it makes no difference. And here my dipole, which is 17.5 feet above a horrifically bad ground, puts that old BS theory to rest. Or it actually further refines it. Yes, the ground is horrible for ground radials with a vertical, but not for a dipole with this kind of field coupling, which is that kind of field coupling, and the magnetic line, if the charge on the wire is moving, the magnetic lines are coming as an arrow from the point down here at the bottom, either toward or away from us. So it's kissing off the ground and coming around in a curve. The term is curl. But this is an approximate proof of the previous video that I did of what is not an antenna, and going over into the idea of charges in the quantum world. Remember QED, quantum electrodynamics, and in the nuclear world from charge compression, concerning these charges and their associated traveling fields at very high velocity and charge collision. Now, if you look at that diagram and see there's nothing going up, that puts to rest this BS about NVIS. If there's nothing above the antenna, there's nothing for field lines to couple to, therefore energy isn't going up. Notice it's conserved under the antenna wire. Another critical principle. In the next video, I'll show you the principles that I used, just common, easy observations about dipoles that led me to discover these quantum theories. And they're exactly right, just without the mathematics. And the mathematics is not really enough to do what we want to do in amateur radio, and that's build some form like a dipole and optimize it. And that's what I used those principles that I figured out to do. And again, 20-meter dipole, 17.5 feet off the ground, about 5/8 of a watt, 5/8 into Europe. That is not supposed to happen. Okay, BYP out.